Welcome to Variation Visualized, our new series designed to explore the powerful, time-saving capabilities of CETOL 6 Sigma, the model-based tolerance analysis tool built directly into your favorite CAD software. In this video, we'll be setting up a measurement, an intuitive representation of a tolerance stack-up that forms the basis of CETOL's model. Look out for other upcoming videos in the series to get a full picture of CETOL's workflow. Today we're going to set up some measurements in CETOL 6 Sigma. Measurements are the tolerance stackups which CETOL's fast, powerful model uses to provide insights into your product's key requirements and specifications. You can quickly measure between physical features like edges and surfaces, or you can use virtual geometry like center planes and midpoints. The result's a fast, intuitive way to build your stackups directly around what your product needs. So let's take a look at how we define measurements inside CETOL. CETOL has multiple versions which integrates with models from SolidWorks, Siemens NX, Creo, and CATIA. Today and throughout this series we'll be using the CATIA version, but these steps will transfer over to any version of CETOL you happen to be using. Here you can see we have a simple model of a caster wheel. And let's start by measuring the distance between these two flat planar surfaces on these two axle supports here. So I'll start by adding in these axle supports as components, and although you can see the entire CAD model here, CETOL's model tree on the left here will only contain the components that are being used as part of your model, either as measurement references or to define the functional relationships between your parts and features. So let's go ahead and add in these two axle supports as components. And once I've done that, I can set up a measurement between this inner surface here, which I can rename to keep track of it, and this second inner surface here. And then I can rename the measurement here to keep track of it as well. So let's call this the inner surface gap, and then I can finish up my measurement like so. And now we can see the measurement has appeared in the measurement tree on the left. CETOL has indicated the measurement endpoints by this helpful little green arrow here, and on the right we have an overview of the measurement properties. Now that I've created a measurement, I can start thinking about what my requirement for that measurement should be. So I can just head over to the Requirements tab here and start setting the limits on how strictly this measurement needs to be controlled. And if I need requirements on statistical quality to be satisfied, I can also set this measurement as an objective. This is ideal for a critical functional requirement, since I can ensure that a certain percentage of my manufactured assemblies will keep this measurement under the control that I require. And if I wanted to adjust the quality of this measurement, then I could go ahead and make this plus minus 0.05, for example, and then that would be adjusted within CETOL's model. By default, you can see that we have a linear measurement here, but we could also change this if we wanted to an angular measurement, measuring the angle between these two planes. Or we can change it to a special case of linear measurements like gap or flushness measurements. But let's just leave this as linear for now. So now let's look at the measurement location. So as you can see from the arrows, the measurement endpoints have been indicated here, and I can highlight the start and end features as so. And next to the start and end feature, you can see these lock icons, which indicate whether the measurement endpoint is locked or unlocked. That's whether it's allowed to vary across the entire surface here, or is taken from one particular point. And I can select that point if I so desire from the CAD model by using this Select Location tool here. So for example, I could take the measurement from this edge here, which is closer to the axle holes if I so desired, and now you can see that the measurement location has updated to reflect that. And here we're adding measurements as the first stage before the rest of the model has been constructed. However, we can easily add more measurements at any stage in the model, even after the contributors and joints have been defined. You can refine your analysis as your understanding grows without having to start all over again. Measurements will also support annotations and internal notes, which can be ideal for complex models with multiple team members or ongoing revisions. So I could, for example, make a note here that this measurement is version 1, or I could include some user-defined parameters to tie together particular measurements or change how they would appear in reports. And that will do it for this brief demonstration video. I hope I've been able to show you just how robust and easy to use CETOL's measurement system is, and how it can easily fit any requirements that you or your team have about your product's performance. Stay tuned for more videos in our Variation Visualized series, or learn more about the concepts behind tolerance analysis in our Tolerancing Tooltips series. Thank you for watching.